Can a bullet really stop a train? It's a question that might have crossed your mind while watching a Hollywood blockbuster. Now let's take a moment to consider the sheer power of a bullet. When fired, a bullet can reach astonishing speeds, tearing through the air with tremendous velocity. It's a tiny object, but the energy it carries is immense, all focused and concentrated in a small area. This concentration of energy is what makes a bullet so devastating, the reason it can shatter glass, pierce metal and cause such destruction. But how does this power measure up against the might of a colossal roaring train? A train, after all, is a behemoth of steel and power, an unstoppable force in its own right. So can this concentrated energy of a bullet, this tiny but potent force, really be enough to halt such a massive object in its tracks? Let's delve into it. Scene script. Trains, on the other hand, are behemoths of steel and power. They weigh thousands of tons and move at incredible speeds. Imagine, if you will, a locomotive. These mechanical beasts are constructed from tons of solid steel, iron, and other heavy-duty materials. The heaviest freight trains can tip the scales at an astonishing 4,000 tons. That's the equivalent of 2,000 average-sized cars. Now let's consider the speed. Even a slow-moving freight train can reach speeds of around 50 miles per hour. But passenger trains? They're a whole different breed. High-speed trains can easily clock in at over 200 miles per hour. That's faster than the top speed of some sports cars. But it's not just about the weight and speed alone, it's about the energy. When a train is in motion, it carries an enormous amount of kinetic energy. Kinetic energy, if you remember your physics classes, is the energy of motion. It's calculated by multiplying half of the object's mass by the square of its speed. So when you have a 4,000-ton train barreling down the tracks at 50 miles per hour, the kinetic energy is mind-boggling. It's like a rolling thunderstorm, unstoppable and powerful. Now think back to our bullet. Even the most powerful bullets carry only a fraction of the energy of a moving train. A high-powered rifle bullet, for instance, carries roughly 5,000 foot-pounds of energy. That's a lot for a tiny piece of lead, sure. But compared to a train, it's like a mosquito trying to stop a hurricane. And this brings us to the heart of our question. Given the enormous weight and speed of a train and the colossal amount of kinetic energy it carries, could a bullet really stand a chance? Could it, despite its minuscule size and energy, halt the unstoppable force that is a train? With such a massive disparity in energy, could a bullet truly halt the progress of a train? Scene script. Picture this. A single bullet, fired directly at an oncoming train. What would happen? Let's embark on a journey to the realm of theoretical physics to answer this seemingly simple question. Imagine we're in a world where bullets and trains are the subjects of an unusual experiment. Our bullet is standard issue, a .45 caliber round, known for its speed and impact. The train? A colossal steel beast, thundering down the tracks at a steady 60 miles per hour. The bullet, fired from a distance, travels at an approximate speed of 800 feet per second. Now what happens when these two forces collide? To understand the outcome, we need to delve into two key principles of physics: momentum and kinetic energy. Momentum, in simple terms, is the mass of an object multiplied by its velocity. Kinetic energy, on the other hand, is the energy which an object possesses due to its motion. The bullet, despite its impressive speed, is dwarfed in mass by the train. So, when calculating the momentum of both, the train's momentum significantly outweighs the bullet's. This is because the bullet's high velocity is offset by its low mass, while the train's high mass compensates for its relatively low velocity. Kinetic energy, however, is a different story. It is calculated by the formula 1/2 mass times velocity squared. The bullet, due to its high velocity, possesses a considerable amount of kinetic energy. But even then, when compared to the kinetic energy of the moving train, the bullet's energy is just a drop in the ocean. So what happens when our bullet finally collides with the train? Well, the bullet will certainly make an impact, possibly even denting the surface of the train. But the train's journey remains largely undisturbed. This is due to the principle of conservation of momentum. The total momentum before the collision, which is the sum of the momentum of the bullet and the train, is equal to the total momentum after the collision. The bullet's momentum is absorbed by the train, causing a minute change in the train's velocity and direction. But this change is so small that it's practically imperceptible to the human eye. It's like throwing a pebble into a pond and expecting the ripple to cause a tsunami. It simply doesn't happen. What about the bullet's kinetic energy? Well, most of it is lost in the form of heat, sound, and deformation energy when the bullet hits the train. The remaining energy that is transferred to the train is insignificant compared to the train's initial kinetic energy. This hypothetical experiment shows us that the world of physics is a place of balance and conservation. It's a place where a tiny bullet, despite its speed and energy, cannot stop a massive moving train. So it seems that a bullet's energy is simply too small to halt a train's massive momentum. Scene script. Are there any real-world examples that could shed some light on our question? To answer this, let's delve into some instances where trains have encountered objects with similar or even greater energy than a bullet. Trains, due to their massive size and momentum, have often been hit by various objects without coming to a halt. Take, for example, the common occurrence of trains hitting rocks on the track. A rock, depending on its size and the speed at which the train is moving, could have a kinetic energy comparable to that of a bullet. Yet, in most cases the train carries on, perhaps with some damage to its undercarriage, but still very much in motion. Then, there are instances of trains colliding with vehicles stuck on the tracks. These vehicles, whether it's a car or a truck, far outweigh a bullet and have a lot more energy when stationary. However, the result is often the same. The train might slow down due to the impact, but it rarely stops completely. Remember, the train's enormous mass and high velocity give it an extraordinary amount of momentum. This momentum allows it to plow through obstacles that would immobilize smaller, less powerful vehicles. It's a simple demonstration of Newton's first law of motion. An object in motion tends to stay in motion unless acted upon by an external force. Of course, all these examples are not perfect comparisons to a bullet hitting a train. A bullet, although much smaller, is fired at a much higher speed, and its impact is concentrated on a much smaller area. However, they do illustrate the principle we're exploring here. That a single bullet, on its own, is unlikely to have enough force to stop a train in its tracks. As we can see, even objects with similar or greater energy than a bullet fail to stop a train. So, next time you're watching a Wild West movie and you see the hero trying to stop a runaway train with a well-placed shot, you'll know better than to believe it. So, can a bullet stop a train? A question that might have crossed your mind at one point or another, especially after watching a particularly thrilling, action-packed movie sequence. We've journeyed through the realms of physics, engineering, and a dash of cinematic imagination to unravel this mystery. Firstly, we delved into the power of a bullet. A bullet, small as it may be, packs a punch. It's designed to concentrate a significant amount of energy into a minuscule point. When released, this energy can cause substantial damage to its target. However, the question remains, is this energy enough to halt a train? To answer that, we journeyed next into the might of a train. A train, in all its majestic enormity, carries an incredible amount of momentum. Momentum, as we've learned, is a product of mass and velocity. With a train's colossal mass and its speed, it's safe to say that its momentum is nothing short of massive. We then ventured into a hypothetical experiment, a world where we could pit a bullet against a train in a controlled environment. Despite the bullet's concentrated energy, it simply does not carry enough force to stop a train. The disparity between their respective momenta is simply too vast. This conclusion is further cemented by real-life instances. There have been incidents where trains have collided with far larger and heavier objects than a bullet, and have continued on their course. These instances prove that a bullet, despite its destructive power, is no match for a train's unstoppable momentum. In conclusion, the answer to our question is a resounding no. A bullet, no matter how powerful, cannot halt a train in its tracks. The laws of physics simply won't allow it. So the next time you find yourself engrossed in a movie scene where a bullet stops a train, remember, it's nothing more than a work of fiction. While it might make for an exciting movie scene, in reality, a bullet cannot stop a train. Physics has spoken.